Okay, in this video we discuss how to calculate and graph stock returns. We're going to be focusing on simple, log and cumulative returns. The first thing we need to do is to import the appropriate libraries in order to get the data we need. We're going to be calling the Yahoo Finance library as YF. Next, we defined a list of assets that we're going to be using for this example. So we save them into an object called ticks inside our Jupyter lab session. So we're going to be using Facebook, Apple, Amazon, Netflix, and Google. We run this line and we have saved this object. And next, what we do is to call the Yahoo Finance library with the method downloads, and we include as arguments the list of the stocks that we're going to be using and the period of time that we want to get the information. We're going to be starting from the 4th of January 2016 and then up to the 30th of April of 2020. We run this command and we can check that we have the correct information. So in this case, it is the case. We have information on the 5 stocks and on the different types of prices. However, the thing that we need to do is to save this data set into this pandas data frame into an object in our Jupyter Lab session. And we're going to be focusing in addition on only the adjusted close price. So we do this by writing this command. The object is going to be called FANG. This is the portfolio of assets, and with this specification, we define the appropriate price that we need to use. So we run this line, and it is already saved into our Jupyter Lab session. We can take a look at the first 5 rows and to the last 5 rows. So now we have the object that we need that includes the pandas data frame for the FANG portfolio. So we can right away start calculating the first thing, which is going to be the absolute changes between 2 index values. So this is, in this case, it is between 2 prices. So what is the absolute difference in price in the price of Apple for the 24th of April relative to the previous day, which was the 23rd of April. So this is very easy. We're going to be calling the object that we just created and apply the method diff. So in this case, we have the absolute difference between 2 index values, the absolute changes between 2 index values. The next thing that we will do is to calculate the simple returns in the form of the percentage changes. So we call the method percentage change to we apply it to the object FANG. So percentage change, we run this command and we have the simple returns. Now this is, we can improve we can make this data set easier to see, improve the visibility of a data set by applying, for example, first of all, of course, the percentage change in order to calculate the simple returns, but then adding the method round because we only want 3 decimals, for example, and then applying the drop in a method in order to get rid of the missing values included in the first row, which are not a number values. So we get rid of all of these and we clean a little bit the data set and we get these results. What we can do now is to graph the returns in the form of you can have several possibilities to graph them in a bar plot, in lines, and so in order to track the evolution and so on. So the first thing we can do is to take a look at a bar plot that shows the mean returns or the average returns of each of these assets. So we're going to be calling again the percentage change method, but in addition we will add the method mean. To these we add plot, and inside as an argument we define the type of plot that we want. So we also set, in addition, we set a figure size. I'm going to be setting it to 12 and 8. If we run this line of code, then we obtain a graphic, a bar plot, showing the average returns of each of the individual assets included in the FANG portfolio. Of course, as an alternative to the simple returns, to the percentage returns, we have the log returns. So normally in a financial context, they are easier to handle and they're going to be the preferred type of returns. So let's take a look at the calculation. So first of all, we need to import the appropriate library, NumPy as NP. And we start setting the name of the new object. So we call the NP library, the NumPy library, and we use the method log. Inside the parentheses, we're going to be using the calculation. We're going to be defining the calculation of the log returns, which is going to be the following. And we shift by 1. So what we included is the calculation. It's a division of every single price of each of the assets included in the portfolio FANG divided by the previous price. So this is the price at time t divided by the price at time t minus 1. That is why we specified shift equals to 1. So we run this line of code and we take a look at the results. So as you can see, you have the log returns of your portfolio of assets, well, of each individual asset included in the portfolio. We can do the same thing with regard to the visibility of our pandas data frame to round the numbers to 3 decimal points to get rid of the missing values and to take a look at the first 10 rows. So we can see we have a better visibility with regard to these log returns. The last thing that we can do is to calculate that we're going to be discussing is to calculate the cumulative returns, the graphing and the calculation of the cumulative returns. So to do this, we're going to be starting with the object that includes the logarithmic returns. And of course, we're going to be applying the exponent method that is included in the NumPy library. So we called the object logret and we apply it the method comSum. So let's take a look at the first 10 rows and we have the cumulative returns in this case. This is a way to calculate these cumulative returns. However, it is not the most efficient. If you want to improve your manipulation of the data set, you can do it in the following way. So logret comSum, the method cumulative sum. And then we're going to be using the apply function, which is extremely useful in the Python language. As an argument, we're going to be using the exponent function in the NumPy library. What does this do? Well, it is the same as this one. The only thing that we're using in addition is the apply method. This method is going to be applied to the cumulative sum and is going to be applying the exponent function to each of these columns for each of the observations that we have, for each of the days that we have. So what is the advantage of using the apply function? The advantage is that you're going to be able to include more arguments into this line of codes, which will enhance your manipulations of your dataset. It will give you more possibilities to manipulate your dataset. So we run this command, and as we can see, it provides us with the same information, with the same pandas data frame as previously. How can we graph these returns? So we're going to be calling the object, applying the comSum, and then using the method apply with the exponent function of the library NumPy, and then we're going to be calling the plot method. Inside the plot method, we need to take, this is an optional argument, the figure size. I'm going to be using 12 and 8. And in addition, in order to improve the visibility, I'm going to be adding a grid. So if I run this command, what I obtain is a graph of a plot, or a plot of the cumulative returns for each of these of the assets that I included in the FANG portfolio.